Hi, I'm Miss Hall, and this is lesson 1.7, solving equations with variables on both sides. Let's go through the steps of how we're going to do this. If we find an equation with variables on both sides, we're going to simplify one or both sides of the equation if necessary. So think we're going to be combining like terms or using the distributive property. So we might combine like terms, or we might use the distributive property. And then after we've done that, after we've simplified both sides, we're going to use inverse operations to collect variable terms on one side and collect the constant terms on the other side and isolate the variable. Let's hop right in. Example 1, we're going to solve this equation and check our solution. So there's a variable on both sides. I should begin by saying each side is as simplified as we can make it. And now let's get the variables all to one side. Because there's no constant term over here as well. A constant term is just a number, like positive 9 or negative 10, right? And the variable terms are the ones that have a variable. You'll see a lot of these, it's x, so maybe 3x or negative 2x are variable terms, doesn't have to be x. Because there's no constant term on the right side, I'm going to move the variable terms over there. So the inverse of negative 4x is adding 4x. When I add 4x to both sides, I end up with 10, nothing, and negative 5x. Now I've isolated the variable term on one side, so let's now isolate the variable. The inverse of multiplying by negative 5 is dividing by negative 5. And here we have negative 2 equals x. We're also meant to check our solution. So let's go back to the original. 10 minus 4 times negative 2. Does that equal negative 9 times negative 2? And we have 10. This is a multiplication. I'm going to do negative 4 times negative 2 equals positive 8 equals negative 9 times negative 2 is 18. And 18 does equal 18. We are all set. Let's do another one. This time with grouping symbols. So we need to simplify both sides. Here we go, the distributive property. 3 times 3x, 9x, 3 times negative 4, minus 12 equals, and we've got the distributive property over here. If you want to make notes for yourself, this is 1/4 times 32x, which I can really put over 1 and multiply the numerators and get 32x over 4. This is 32 divided by 4, which is 8. So I really have 8x, and then I have 1, running out of room, 1/4 times 56. This is over 1, so this is 56 over 4. And I would need to do this with long division or a calculator. I don't happen to know how many times 4 goes into 56, so let me go 56 divided by 4. 14, and I end up with positive 14. All right, this is all, I'm going to put thought bubbles around it. This is all what's going on in my head. You do not have to write this out unless it's helpful for you. Let's see, everything, there's no like terms, so it's time to isolate the variable terms on one side. I like moving so that I get a positive variable term. You don't need to, so I'm going to move the negative 8x because I see that that's going to give me 1x. Right, it's going to give me x. And then I'll be moving this 12. And I will get x equals 26. There we are. And then to check my answer, I would put 3 times 26 minus 4 and compare that to 1/4. 32 times 26 plus 56. I can already tell you with this right side, I'm going to be using a calculator. So let me pull this in. Let me put the left side in. 3 times 26 minus 4. I get 222. And then I'll do 1/4 times 32 times 26 plus 56 also equals 222. So this checks out. Now we've got special cases, so special solutions of linear equations. So equations do not always have one solution. That's what we've seen so far. An equation is true for all values of the variable, is an identity, and has infinitely many solutions. So you're going to find infinitely many solutions when you end up with something like 2 equals 2. You've somehow gotten rid of the variables, and you've got some number. It doesn't have to be 2. It could be 0 equals 0. That's infinitely many solutions versus an equation that is not true for any value. Variable has no solution. So no solution, you can think if we end up with something like 2 equals 0 or 3 equals 1, those aren't true. That means there's no solution. Helps just to do some examples. So let's do this. We're going to distribute as we simplify each side, and we get 15x plus 6 equals 15x. You might be telling yourself, I'm going to already anticipate that this is impossible for 15 times some number plus 6 to be the same as 15 times that number. And you're going to see that that is correct. Let's get the variable term on one side. And so we end up with 6 equals 0. Well, that's not true. So in this case, what we can write is there is no solution. No solution. There is no value of x that would make this true. Okay, versus this one. What do you know? We start with the distributive property as well. We get negative 8y minus 2 equals negative 8y minus 2. And you might be saying that like, so that both sides are equal. They equal the exact same expression on both sides. That's going to end up being any number times negative 8 minus 2 equals that same number times negative 8 minus 2. And you would be right. Let's follow this through. Let's move this 2 over here. So we'll add 2 to both sides. And we will get negative 8y, that's a 0, equals negative 8y, that's a 0. And then I want to get the y's together. So I'm starting to hesitate because I'm like, this is bizarre. I'll add 8y to both sides. And I will end up with 0 equals 0. And if we get something, a value equal to itself, that means that there are infinitely many solutions. So let me write that. Infinitely many solutions. Those are your special cases. Let's move to the try it, unpause, and watch the solutions once you've tried it on your own. Let's isolate the variable terms on the left. So I get 20k plus 7 equals negative 3. Let's isolate the variable 20k equals negative 10. Instead of multiplying by 20, let's divide by 20. We will get k equals negative 1/2. It's a good habit to check your solution. I'm not going to do that for this problem specifically for either. Try it because I feel like I'm going over my time and you can check on your own. Now let's do the next one, which is the distributive property. 1/2 times 6x, or 6h is 3h, minus 1/2 and 4 is 2. I'm going to isolate the variable terms over here. 8h minus 2 equals 1. Let me add 2 to both sides and get 8h equals 3. I will divide both sides by 8. Get h equals 3/8. And again, you can go ahead and follow the steps to check your answer and see that that